Hi. Hello, everyone. I'm recording this review. I have some students here. And so they asked me the questions. So we're going to go over some topics, and then I'm going to stop it. So the video is going to have multi-parts. So the first question they asked me was the domain of sum, difference, and all that. So given f of x and g of x. Now, you have to understand that when you're looking at the domain of sum, difference is the number one, sum, difference, and multiplication, you are going to look at the overlap of their domains. So what is the domain of f of x? That is all real numbers, right? Because it's a polynomial. And then g of x, that's a line, that's also all real numbers. Now, if you add these guys, where do they overlap? They are going to overlap all real numbers. There is nothing else. So for addition, subtraction, and multiplication of these two functions, the domain is going to be all real numbers because that's where they overlap. But for division, let's say they're looking for the domain of f over g. Let's look at g. G is 2x minus 9. You cannot divide by a 0. Therefore, you have to take the values out that makes this 2x minus 9 0. So in this case, it's 9 halves. So if they're asking you what's the domain of f over g, you have to say all real numbers minus 9 halves, because that's the guy that makes the g 0 that happens to be in the denominator.
You only have to find out that the denominator.
That's correct. For example, if they're asking me, let's say they're asking me what's the domain of g over f. Okay? The same g and same f. Where is function f 0? It is 0 when x is 0, right? So if they're asking domain of g over f, your domain is going to be all real numbers minus 0 in this case. So you need to take out values that makes the denominator 0. That's the only restriction. All right? All right. So that's question number 1. Factoring cubes, question number 2. You guys asked me. You have to memorize, since you're going to have a closed book exam, you have to memorize for number 2 for the cubes. You have to memorize a cubed plus b cubed factorization and a cubed minus b cubed factorization. So, do you guys memorize that? Did you memorize those? No, a plus b, a squared minus ab plus b squared. So you have to remember, when this is plus, this is minus. For the minus one, you're going to have a minus b, a squared, plus ab. It's always the opposite, plus b squared. So somebody's asking you, factor, okay? Factor, let's say x cubed minus 8. So the cube should kind of trigger, it's a cubic factorization. The first thing I would do, I would write this as a difference of two cubes. And this happens to be x cubed minus 2 cubed. Does that make sense? Now this is your A, this is your B. Apply the formula. How does that work? A minus B, which is x minus 2. Then the first term is going to be the first term squared, which is x squared. And since it's minus, it's going to be plus the multiplication of the 2x plus 4. Since we are here, I want to actually talk about, I do that in my class, the difference between factor and solve. So when somebody says factor, you're done with this problem. You just factor and you're done. This is the answer. I have hiccups, I'm sorry. If they ask the same thing and then they say solve, it's cubed minus 8 equals 0, for example, it's an equation. You first factor, and you need to know the factoring. Then for the zero product property, you have to set each one to 0. This one is going to give you x equals 2. And guess what? This guy is never 0. So the answer is x equals 2 to the question solve. So you give this answer when they say factor, you give this answer when they say solve. Yes?
Why would that ever equal 0?
Because it's prime. It is the parabola that is floating up or floating down. It never gets close to the x-axis.
Is that only with that question specifically, or is that with any question?
For the cubics, this long part is going to be prime, it's never 0.
Okay.
For the cubics. All right? So that answers your 1 and 2. Number 3, let's do that. You have to really know, and I did ask that, how to solve formulas. So 1 over r plus 1 over t equals 0, equals 1. So let's do that. You asked me? All right. Now, when you have rational equations, what is the steps that you need to follow? You need to get rid of the rational expressions. So you need to get rid of this r and t in the denominator. What is the procedure? Multiply by the LCM. What's your LCM? RT. So what you do is you just put this multiply both the left and the right by RT. That should get rid of the denominators. When you do that, r's go away when you FOIL. You'll get a little t plus the little t's go away. You have big R, and on the other side you have r times t. That's a little better. Now what am I solving for? Solving for r. Now, when you have formulas, think of what you're solving for is like an x and everything else like a number. When you had this, you would, if you had x like on both sides of an equation, you would put them on one side and then numbers on the other side. So that's what I'm going to do. I'm going to subtract. Now I'm going to have t plus r minus rt equals 0. Now, everything that doesn't have r in it behaves like a number, so I need to subtract t. So what do I have? R minus RT equals now negative t. Does that make sense? I'm solving for r. That means I want r by itself. Look, this is the step you really need to understand. I pull the r out. 1 minus t. Do you see that? I the distributive property and factored out. Now, what am I going to do? I'm going to divide by that coefficient. So you have r equals negative t over 1 minus t, which is the same as t over t minus 1. Ta-da, you're done. But that step you have to understand, the distributive property step for formulas. Does it make sense? Now, let's look at what else you guys asked me. 3, 4, word problems. I'll come back to that. Graphing with shading, right? So for that one, I need to give you a couple of questions that I just had in class. Let's say you have any one of these. This is two variables. Y is less than x. Let's say x is greater than or equal to 3. less than or equal to x plus 1. You have a system and you need to solve this system. The question is solve. What you do is, I do this with colors. Oh, you know what? For longhand portion, so bring some color pencils so that you can do these problems a little easier. Y is less than x. What does that mean? So I'm going to do this in the red. Y is less than x. Y equals x looks like this. You understand that, right? So since it doesn't have an equal, so it's going to have dotted line. Y is less than x, so you do your test point, it ends up getting shaded like this. How do you decide that you shade this side? You have a test point. For example, let's say I picked this test point, and that point is 1, comma 0. I put it in y less than x, so 0 less than 1. Is that true? True. Therefore, I have to shade the side that contains that point. That's the test point method. Now, so I got that red done. So let's do this one. X greater than equal to 3. What the heck does that look like? X greater than 3, so that is 1, 2, 3. So that is a vertical line, yes? So since it has equal, so you have to have a solid line, right? And now pick a test point. Let's say I pick this point, 0, 0. I'm just going to test it. 0, is that greater than equal to 3? Of course not. That's not true. So what does that mean? I need to shade the opposite side. So I need to shade this part. All right? So let's go and let's kind of extend this so that you know where things are. So I'm going to do the third one. I will do that in green. 2x plus 1. What does that look like? Here's your 1. 2 means you go up over 1. So you're going to have to have, and this is solid line, some like that. Now, y is less than that. Then have a test point of 0, 0 again, and let's check that. 0 is less than or equal to 2 times 0 plus 1. Is that true? Yes, it is true. What does that mean? That means I'm going to shade this part. That's why you need colors. All right? Now you have to look at it. Where does the green, red, and blue overlap? Okay, well, I don't know. I have to kind of look at it. That green doesn't have the red, so they overlap in here. So you have this blue, so it looks like it is high up there because I don't have room, but it looks like it is high up there where the green, blue, and red. So because you have a situation like this, you have green going like this, red going like this, all right? And then blue is going like this. And then you just color this. So if you were to do this thing way up there, do you see it? So you need to have, I don't know if you're going to be able to even intersect all these three colors. So you have the red this way, blue this way, oops, blue that way, and green this way. I mean, I have to do this red that way. So red and blue, they intersect around this area, but this one is going to intersect here, right? So it looks like green, red, and blue, they're going to have to intersect somewhere here. Do you see that? Somewhere here. Let me do this in purple. So it's going to have to be here and here. You see it? Has to be somewhere like that. Ah! Sorry. Okay, let me come. I know that undo erase. Here we go. Do you see the purple part? And that's what you're supposed to do. Just look at it. It's kind of like tedious. Problems are going to be a little prettier looking. But that's how you do it.
Are we gonna have them like that?
In the longhand portion, you may.
Let me just rewrite my pen.
Bring some, let's see. You need to do it, but you have to kind of, multiple choice portion will have that. So you don't have to do this from scratch for the midterm, but in the final let me ask that. Right? Okay. So that's the shading. Does this help? What else did you say? Oh, absolute value, and then I'm going to stop the video, and then I'm going to go to part 2. So let me, selection tool. So let me copy that. Here you go. Here's the problem you wanted. Alright. So they kind of worded this thing in such a way that they said, oh, when is, they gave you the f of x, and they said, when is that thing less than 17? So you need to know your absolute value inequalities. So how do you do this? To do an absolute value inequality, you need to isolate the absolute value. You need to isolate this thing. Alright, so what am I going to do? I'm going to subtract 6. So you have 2x minus 1 less than 17 minus 6, 11. Alright, this has two parts, right? Because absolute value can be negative or positive. You have positive 2x minus 1 less than 11, or negative 2x minus 1 less than 11. So you just have to solve that. You have 2x less than 12, x less than 12 over 2 is 6. Let's do the other part. You have negative 2x plus 1 less than 11. Negative 2x less than 11 minus 1, 10. You divide by negative 2. So what are you going to have? You're going to have x greater than negative 5. So you have a situation where they overlap. X less than 6 and greater than negative 5. What does that mean? X is between negative 5 and 6. Ta-da! You can show it like this, or you can show it in interval notation, negative 5 to 6. Or you can say x such that, that's the set notation. X is between negative 5 and 6. What else do you have? You can have number line notation, and then put 0, negative 5, and 6. So you have this situation, this notation, this notation, this notation, and that notation are perfectly fine for this. Okay, so let me save this thing. And